Hello guys, in the last class we were discussing about high torque rotors, high rotor torques, and I told you it's with respect to squirrel cage, as in slip ring induction motor we don't require of such arrangement, as we know that we're going to add resistance in the rotor circuit in series so that starting torque is increased as well as starting current is limited. Okay, and when motor achieves to 70 to 80% of the rated speed, what we are going to do is we are going to slowly remove the resistance, so that what happens, slip will be very less, and again normally your motor starts to work. So normal functioning will be there depending upon the low torque, low demand and all. Okay, now in the last class we came to know that due to skin effect, what happened, the current concentration will be less at the center, whereas current concentration will be high at the surface. Okay, due to skin effect and all, right? Again, one thing we know that due to the center part will offer high impedance, whereas your surface part will offer low impedance, such that current is pushed to the surface. So you can see the starting current was high here, but here in the center you can see current is less. Okay, the distribution of current is less and the distribution of current is more in the surface. So what I can say is there is a non-uniform distribution of current in this particular rotor bar. Okay, so my question is whether this non-uniformity of distribution of current will be same throughout the operation of the induction motor, of your squirrel cage induction motor. The answer is no. Okay, let us see what happens later. Only we think what require is the current should be limited as well as the starting torque should be increased only during starting. Okay, if that is continued throughout the operation, then what happens, due to the offering of high resistance, there will be losses will be more, as well as the slip will be also more, as well as efficiency will be less and the performance of the motor will be poor. Okay, so that's why we need to have more resistance only during, or you can call high resistance only during at the starting, so that initial starting torque is increased. Now let us see how this is reduced. How this is reduced in sense what? How the starting resistance is reduced. As I told you, due to skin effect, what happens? Area of cross section will decrease. If area of cross section will decrease, means the resistance of the conductor will increase. This is what we learned in the skin effect. Yes or not? So what we learned in the skin effect, this part, right? Now with this knowledge, let us see one equation. So this is the equation. We know that rotor frequency is equal to slip times of that of stator frequency. Fr is rotor frequency, S is slip, whereas F is stator frequency. Okay, and we know that at starting slip value is equal to 1. True, slip value is equal to 1. So Fr will be equal to F. So rotor frequency will be equal to stator frequency. If stator frequency is 50 Hertz, then rotor frequency will be also 50 Hertz. And again from this picture, it is very much clear that as frequency increases, yes or not, as frequency increases, skin depth will also what? Decrease. Means the area of cross section will decrease. Yes or not? You can see area of cross section is decreased here as I have increased the frequency. Yes or not? If I decrease the frequency, what happens? You can see area of cross section is increased here when compared to this. Yes or not? So with this knowledge, what I can say here is, at starting S equal to 1, so Fr is equal to F, so stator frequency is 50 means rotor frequency is 50. Now what happens, now let us say your motor has started, now slowly it has started with high resistance, low input current or low starting current, your motor is acting now as a high starting torque. Okay, now motor started, so obviously motor will gradually reach its normal speed. So when motor reaches normally 70 to 80% of the rated speed, then obviously what will be the value of S? Yes, now initially slip value will be 1, but now what happens, slowly the slip value will decrease. Yes, it slowly decreases and it reaches to around 1 or 2%, or you can say 3%. Okay, 3% means it is 0.03 of the stator frequency. So Fr is equal to 0.03 of stator frequency, means the rotor frequency will be also very less. Yes or not? 0.03 of 50% will be what? 50% means 50 Hertz means it will be very less. Yes or not? So the rotor frequency will decrease. Yes, this what concept I required to explain this. When rotor frequency decreases, yes or not? You can see When rotor frequency of decrease, what happens? The area of effective area of cross section will increase. You can see before it, let us say this is example for 50 hertz. So what happened there at starting? Initially you can see area of cross section is very less and skin depth is also less. But here what happens? Once the frequency of the rotor decreases, the area of effective area of cross section will increase. Thus what happens? If increase means the resistance offered by the conductor will also decrease. Thus what happens? Current will start to flow uniformly throughout the conductor. Okay, still slowly again slip will be around 1% finally. Again 1% means only small white part will be there, means almost like it is approximately 98 or 99%, you can call like this. 98 or 99% of your conductor will be having its cross section area, so that current will be flowing throughout smoothly. Okay, there will be no any uneven distribution of current in the conductor when the frequency decreases to 0.01% or 0.01 times that of rated frequency, because we know that slip value will be around 1 to 5% of the induction motor, yes or not? So slip will be around will be very less during its normal speed, during its rated speed. So what happens there? The effective area of cross section will increase. If effective area of cross section will increase, then what happens? The resistance will decrease. If resistance decreases, means what? The current is distributed uniformly throughout the conductor. Okay, hope you understood this. So only what happens during starting, the current will be what? Less, and the resistance will be high. Okay, by using the deep bar rotors. Then throughout, after that what happens? After that, when the motor reaches slowly picks up the speed, then what happens? Slowly the slip value will also decrease. If slip value decreases, then what happens? The rotor frequency will decrease. If rotor frequency decreases, means what happens? The current will try to flow completely throughout the conductor. Okay, it is not like it only flows on the surface part, it also flows in the one center also. Okay, and here you can see this is the diagram of what this is the diagram of resistance versus frequency. Okay, this is the diagram of resistance versus frequency, and again you can see the ratio is defined as AC effective resistance by DC resistance. Here one thing which you need to remember is DC resistance is always constant and AC effective resistance will always change depending upon the frequency of AC supply. Initially you can see for 80 hertz what happened, as the frequency has increased, yes or not? For the frequency of increase, what happens? The resistance will value, the ratio of resistance value will also increase, yes or not? Because the value of AC effective resistance is more, yes or not? Yes or not? True, no? Because the frequency, if it increases, you can see the resistance offered by the conductor will be also more, means the area of cross section will be less and the resistance is more. Hope you understood this. So that's how what happens. If this is high and this is less, then what happens? If I divide high by low, means again the ratio will be high itself. So you can see the ratio is high here. As I go on decreasing the frequency from 80 hertz to 60 hertz, again you can see the ratio has decreased, yes or not? The AC effective resistance will decrease. So DC resistance anyhow it is constant. Dividing a variable by constant, again the ratio will decrease. You can see it has reached over here. Again if I come to 40 means again the ratio has decreased. Again if I come to 20 means again the ratio has decreased, and finally it reaches to what? At the minimum ratio. Okay, so this is what we have a picture of ratio of resistances versus frequency. Okay, means what I'm trying to say here is the skin depth will go on increase as I decrease the frequency. Okay, counterpart is skin depth decreases with increasing frequency. Otherwise I can write it as skin depth increases with decrease in frequency. Okay. Okay, now you can see here we have three speed torque characteristics or slip torque characteristics. So first one, let us go for with low rotor resistance. This is the one of lower rotor resistance. This is the characteristics. We shall discuss about high rotor as well as deep rotor later. So low rotor, you can see that this is the one picture which if you plot means speed versus torque as well as slip versus torque, you will be getting this picture. You can see the torque here is only this much of length, means the starting torque. We know that here the starting torque comes. Here slip it is written as 0, means slip is 0 means your n will be equal to ns. Here slip is equal to 1, means at the start slip is equal to 1 means what? Start only, no? This condition is what? Start. You can see at starting the starting torque is this much. Okay, let us compare the remaining. If I don't make any necessary changes in my rotor, then the starting torque will be only from this point to this point. Okay. Now if I increase the rotor resistance, say if I am using slip ring induction motor, okay, you can see, let us say this is your slip ring induction motor characteristics, and here you can see the starting torque is from this point to this point. So when compared to your squirrel cage, the starting torque of slip ring induction motor, which has high rotor resistance, is more. So starting torque is more. Again, even the starting current will be less because due to offering of more resistance. Okay, you can see. So starting torque is better here. Now coming to the deep bar rotor, whatever we discussed till now, you can see it lies in between middle of the low rotor resistance as well as high rotor resistance. You can see it is middle. This is for high, this is for low, and this is for what? Deep rotor bar. Okay, see, this is what your speed torque characteristics. Okay, it's over here. You can see, yes or not? So here, when compared to your low resistance torque, it was starting torque was this much, but here it is improved. Yes or not? You can improve the starting torque here as well as you can decrease the starting current. So this is what the advantage of having deep bar rotor. Okay. Now second one, second type of your rotor construction is double cage rotor construction. Okay, double cage rotor construction. It is similar. It also works, or it also performs operation as per the skin effect only. Okay, so let us assume there are two cages. The one is the lower cage, other one is upper cage. Okay, this is the iron connected to that particular rotor and all. Okay, and again we can see that there is a constriction in the sense what? A gear gap between upper cage as well as lower cage. Okay, so now once current starts to flow in these two cages, you can see that the concentration of flux at the center is more. So not the concentration of flux at the center is more. Again, as it goes to the surface, the concentration of flux will decrease. Similarly for this also. Okay, like this we can assume a concentric circles here, so that it's similar to the earlier one. Okay, at the center what happens initially, the flux concentration is more, so that means it offers high impedance. High impedance means the current will always try to flow in the low resistive path, so current is pushed upwards. Okay, in the lower cage, so current will try to flow in the upper part of this lower cage. Okay, more current will concentrate at the surface of the lower cage. Now coming to the upper cage, here also it happens same. Here you can see that here also the same thing happens. They have drawn only single dotted line here, circular line. Here also what happens, due to depending upon different concentric circles, the accumulation of flux will be more over here and less will be here, so current is pushed again upwards. So current will flow from here as well as here in the surface. One more thing what you should notice here is the upper cage is made up of high resistive material like aluminum, brass, bronze, whereas your lower cage is made up of material of copper, that is low resistive material. Okay, like I said, your leakage impedance at the lower part is high, so current is pushed to the surface of the lower cage over here. Similarly, here also if I draw some more dotted line circles, here also what happens, leakage flux will be more. If leakage flux is more means the impedance will be high, so current is pushed at the surface of the upper cage of the rotor. So finally what we can understand here is if I apply the resistance formula for the upper cage, so R is inversely proportional to A. Here area of cross section is less, so resistance offered by this upper cage is high. Here you can see area of cross section is little bit more when compared to this, so the resistance offered by this whole lower cage will be less. So this will provide higher starting torque and this will provide lesser starting torque when compared. Okay, so this upper cage is utilized during starting and this lower cage is utilized during running normal condition, that is running at the rated speed. Okay, this will be also contributing during running and this will be also contributing during running, but the contribution made by upper cage will be less during normal speed, that is rated speed. Okay, and the contribution made by this lower cage will be more during running normal speed. And again one more thing is the contribution made by this upper cage at start is high when compared to the lower cage. The contribution is higher when compared to this lower cage. Okay, both have their own roles, so we'll get two different torques from here. Okay, if this and this would connected continuously means if there is no any constriction, let me put in another